Okay, here we go, starting the second part of chapter one. And here we'll get into material that is new. So make sure you do a really good job of, pausing the video, rewinding if you're not sure about something, really paying good attention. If you start to feel like your attention's starting to wane, then, pause it, go, do some push-ups or some jumping jacks or go pet the dog and then come on back. Um, Also remember there's lots of good resources out there. You could always go to Khan Academy, do a search for absolute value equations, take a look at that. Maybe another voice or example would be helpful. Hopefully you'll get it. You probably will with this, but just pay really good attention and really try doing these on your own again. Okay, let's start with this warm up. Determine whether the situation could involve negative numbers, and then explain your reasoning. If you don't want to, just think about it in your mind. You don't have to write it down. If you want to, you certainly can. All right, give it a shot. Pause the video and then come back. Okay, so first one, the number of points one team scores in a basketball game. Well, in a basketball game, a team starts at 0 points, and there's no way to go negative. So I think the answer to that one would be no. Number two, the amount of money in a bank account. Now you might be saying, well, same thing here. You can't go below $0, and technically that's true, but sometimes people will write let's say they had $10 in their account and they wrote a check for $15, and so if the person that they wrote that check to cashes it, then technically they'd have a negative balance of $5. And sometimes banks have something called overdraft protection, which actually allows people to, obviously that's a mistake, like you can't do that, but they like allow or someone to do that for a short period of time. Yes, they have to pay it back, and usually there's a fee. Um, I mean, I think you could say yes there. Then again, you may say no, like you can't go below zero. And then the last one here, the amount of electricity used on this month's bill compared to last month's bill. Um, I put yes because it could go down. So if it went from $80, or the amount used, I guess, went from, whatever kilowatts, and then it went down, you could say that the change or the amount used was a negative. But usually when you're talking about the amount of something, it's in positives. But you could. So those are arguable. All right. So remember, absolute value is a number's distance away from zero. And so go ahead and complete these with a less than sign, a greater than sign, or an equal sign. Okay, we're back. Hopefully for these, you got greater than, because this would be 82 and 57, so that would be greater than. This one, hopefully you got less than sign. Here it would be a less than sign. Here it would be greater than sign. So what you're seeing is the number that's further away, like if you think about it on a number line, it's the number that's the further distance away, whether it's to the left or to the right of zero. The one that's further away is the one that has the greater absolute value. In this case, it's equal, right? Okay. All right, so find someone in your house. You can work with them, do it on your own, do it with your imaginary friend, call a friend, you could FaceTime a friend, you could Zoom with a friend, whatever. Okay, so consider the absolute value equation. Absolute value of x plus 2 equals 3. So notice that's an equation, and we call it an absolute value equation, obviously, because there's at least one absolute value in it. Okay, A, describe the values of x plus 2 that make the equation true. Use your description to write two linear equations that represent the solutions of the absolute value equation. Okay, so go ahead and think about that. Try that. All right, so, what would be the solutions? Well, I know that this side is going to have to equal 3. And if I know when I take the absolute value, it's always going to be a positive. So let's see, if x was 1, 1 plus 2 would be 3, and the absolute value of 3 would be equal to 3. So that would be one of them. So the other way would be if I could get this whole side equal, or what's in the absolute value equal to negative 3, right? Because then when I take the absolute value of it, it would be equal to 3. So what would make this side equal to negative 3 inside the absolute values? Well, the negative 5, right? Because negative 5 plus 2 is negative 3. Take the absolute values, it's 3. 3 equals 3. So Okay, now I'm going to write two equations, two linear equations. Notice it does not say absolute value equations. So what did I solve? I solved where x plus 2, what's inside the absolute values, equals 3. And the other one was I wanted x plus 2 to equal negative 3, right? And like we said, we know it's going to be 1 and negative 5 as our solutions. Notice when we solve this, we get 1. And when we solve this, we get negative 5. So what we're trying to figure out here is how we can use linear equations, again, linear equations, no absolute value in them, to solve an absolute value equation. And think about how you would write that. What do you think, based on what we did? We started with an absolute value, and we wrote two equations, linear equations that don't have absolute values. So what you might write is you can transform an absolute value equation into linear equations and then solve them. All right. Another way, be using a number line. So one thing we can do is same equation, same absolute value equation, x plus 2, absolute value of that equals 3. So on a number line, locate the point where x plus 2 equals 0. Well, what is x going to be for that? Yeah, hopefully you said it's at negative 2, right? So it's right there. B, locate the points that are 3 units from the point you just found. So if we started here, if I go 3 to the right, I'm at 1. If I go 3 to the left, I'm at negative 5. So that might be another way too. Set the absolute value, what's inside the absolute value, equal to 0, and then use this to move both ways to get our solutions. So that could be another way of solving these. Okay. So here are the concepts. And there's a lot on this page, so really make sure that you do a good job of looking at it carefully and absorbing it. And I'm going to go through it relatively slowly. Okay, so the properties of absolute value. So if we let a and b be real numbers, any number on the number line, okay, it can be a fraction, decimal, 7, negative 2.5, pi, whatever. Okay, then the following properties are true. We know that the absolute value of any number, any real number that's on the number line is greater than or equal to 0, right? It's never negative. It's non-negative is a way of saying that, okay? And an example of that is down here. Absolute value of 5, that's equal to 5. Now, I could have used negative 5, put that in absolute values, and that would have been equal to 5, which is greater than or equal to 0. An absolute value is non-negative. It's 0 or bigger, okay? Second one, if you have the opposite of a number, the opposite of a, and you take the absolute value of that, that's going to equal the absolute value of that number's opposite. So here's an example of that. The absolute value of negative 4 is what? 4, right? That's equal to the absolute value of 4, okay? Absolute value of 4 is 4. Absolute value of negative 4 is also 4. They're equal. So opposites have the same absolute value. Okay, third one here basically says that if you have two numbers that are being multiplied together in absolute values, you can split them, still keeping them in absolute value. So here's an example. The absolute value of 5 times 6 is equal to what? How would you write that? Absolute value of 5 times the absolute value of 6. And notice, what's the absolute value of 5? 5. What's the absolute value of 6? 6. We get 30. And here, inside these absolute values, which are grouping symbols, what's 5 times 6? 30. The absolute value of 30 is 30. So they're equal. Okay, and then the fourth property here is similar, except that it's division. Okay? And again, notice B can't be equal to 0 because you cannot divide by 0. That's undefined. So, example, absolute value of 4/9, you could write as the absolute value of 4 over the absolute value of 9. Well, what's the absolute value of 4/9? 4/9. What's the absolute value of 4? 4. What's the absolute value of 9? 9. So we would get 4/9 equals 4/9. Okay. Get rid of this arrow so it's not in your way now. And this one too. So now let's look at the second part of the notes here. Solving absolute value equations. Okay. So to solve the absolute value of ax plus b equals c. Remember, a, b, and c are just numbers that would be filled in this. So like 2x plus 3 equals 4, something like that. Where c is greater than 0 or equal to 0, we basically write them out as two linear equations, ax plus b equals c and ax plus b equals negative c. In other words, if we go back in our notes, we do this. Same thing. So you've already done this. We've already kind of gone through this, right? Here we had x plus 2 and absolute values equal to 3. We rewrote it as two linear equations that don't have absolute values. X plus 2 equals 3. X plus 2 equals negative 3. See how those were opposites? It's that simple. Okay. Now, well, what if c is less than 0? So what the absolute value is equal to is less than 0, a negative. Then we know that's no solution. Why? Can absolute value ever be smaller than 0? Can it ever be equal to a negative number? No. So again, no solution. You're going to write either no solution, you're going to do one of those, one of those, or you're going to do your empty set braces, which again I like to call J Leno. So that's really hard writing with this pad. Anyway, all right, cool. So those are important. Again, split it and set it equal to the opposite. All right, so let's try some of these. If you feel confident with it, go ahead and try them on your own right now. If not, why don't you watch one or two of them and then try the third one on your own. Okay, so here we go. Absolute value of x equals 10, and then we need to graph them if possible, if there's a solution, obviously. Okay, so we could write this, right, as x equals the number on the other side, 10, or what's in the absolute value is x equals the opposite of what's on the other side, negative 10. Pretty easy to solve that one, right? So all we would do on our number line is go and fill in dots at negative 10 and 10. Okay. All right, how about this one? Here we want x minus 1 absolute value equals 4. So doesn't that mean we want what's inside the absolute value to either be equal to 4, or we want x minus 1 to be equal to the opposite of 4. Okay, now these aren't solved, right? We still need to solve them. So what would we do to solve them on this one? We would add 1 to both sides, golden rule of equations, and get x equals 5. And on this side, we would add 1 and get negative 3. And then we would just plot those 2 points. 3, 5, bingo. Okay. Gosh, I don't have very much work shown for this one. Oh my gosh. I don't see any boxes or anything like here that I'm going to uncover on this number line. I wonder why. Ah, yes. An absolute value set equal to a negative. Is that possible? Can an absolute value ever be set equal to a negative? Is there any value you could plug in for x here that would make the absolute value equal to negative 5? No, because absolute value has to be what? Non-negative. So what's our answer? No solution. Okay. All right, we're going to step it up like a half notch here with this next one. It says solve the absolute value of 3x plus 9 minus 10 equals negative 4. And then there's a hint over here. Isolate the absolute value expression first. So notice this absolute value expression is not isolated, right? There's this negative 10 constant on this side. So you want to get rid of that first. So how would you do that? Right, you'd add 10 first. Okay, give that one a shot. Pause the video. All right, so hopefully you added 10 to both sides and you had 6. All of a sudden it's not equal to a negative, so it's a positive, so we know we need to keep going. Okay, so what does that mean? That means we want 3x plus 9 by itself, not in absolute values, to equal 6, right? Because if I take the absolute value, if that's equal to 6, then I take the absolute value of that, that's 6, and that would equal 6. We also know that if 3x plus 9 equals negative 6, when I take the absolute values, it would also equal 6. So that would lead to a solution too. So you'd want to set 3x plus 9 equal to negative 6. Remember, in order to solve these, we have to get rid of the absolute values. Okay? It's part of like when we have to distribute when there's parentheses. Okay, now solve those. So obviously we're going to subtract 9 from both sides. Divide by 3. Go ahead and do this one. Subtract 9 from both sides, combine negative 9 and negative 6, get negative 15, divide by 3, and get negative 5. So our solution would be negative 1 comma negative 5. Okay, and I don't care what order you write them in. You could write it negative 5, negative 1, doesn't matter. Usually you write them from least to greatest, but don't have to. Okay, all right, remember this hint on this next one. So go ahead and try it. There's a little bit more work to do on this one to start with, right? Okay, so hopefully you added 3. Is the absolute value isolated? Nope, still not. We still have this outside of the absolute values. This is being multiplied to that, right? Oh, and by the way, you can never distribute into an absolute value. Super important. People make this common mistake all the time. You can't do that. So what do we need to do to isolate this absolute value of 5x minus 1? We need to divide both sides by negative 2. So what's negative 8 divided by negative 2? 4. Now we're finally isolated here, set equal to a positive number, not a negative, so we know we need to keep going. It's not just no solution. And what does that mean? Well, it means we want 5x minus 1 to equal 4, or we want 5x minus 1 to be equal to negative 4, because then again, when I take the absolute value, it would be equal to 4, and that would be a solution. It would make our equation true. Both sides would be balanced. Okay. So now let's solve that. You would add 1 to both sides, divide by 5, or multiply by 1/5. You get x equals 1. And here, negative 3 and negative 3/5 would be your answer. Oh, and by the way, can we check these the same way? Yep. It's just that we kind of have double work, right? We would need to check both. So let's do that with this one. If I plug in 1, 5 times 1 is 5. Minus 1 would be 4. What's the absolute value of 4? 4 times negative 2 would be negative 8. Minus 3, negative 8 and negative 3 combined together, negative 11. So that one checks. What about negative 3/5? Well, fortunately, when I plug negative 3/5 in, the 5's cancel. So I have negative 3 minus 1, which is negative 4. What's the absolute value of that? 4. 4 times negative 2 is negative 8. Combined with the negative 11, negative 3, excuse me, gets you the negative 11. So they both work. Check, check. Okay? Awesome. Yeah, if you want to put negative 0.6, knock yourself out. It's extra step. You don't need to, but whatever. Okay. All right. So now we're going to learn about writing an absolute value equation that represents the minimum and maximum lengths of something. Okay? So in a cheerleading competition, the minimum length of a routine is 4 minutes. The max length of a routine is 5 minutes. Write an absolute value equation. So one equation that represents the minimum and maximum lengths. Okay? Here's a hint. Find the halfway point between the maximum and minimum values. Okay. So here's what you'd want to do. You basically would set this up by saying the absolute value of x minus the halfway point equals the distance that our maximum minimum are from the end point, or from the halfway point, excuse me, from the halfway point, which would be 0.5, right? 4 is 0.5 away from 4.5. 5 is also 0.5 away from 4.5, okay? Then what would you do? Well, we would do this just like the other equations, right? We want x minus 4.5 to equal 0.5, or x minus 4.5 to equal negative 0.5. Solve those. You got 5, and you got 4. And isn't that way you're checking? Okay. So, because really all we had to do was write this, right? This part was just really the checking. Okay. Find the halfway point between your maximum and minimum, and then figure out what that distance that they are from each of them. Okay. All right. So try this one. Pause the video, try it, and then come back. Okay, for a poetry contest, the minimum length of a poem is 16 lines, and max length is 32 lines. Write an absolute value equation that represents the minimum and maximum lengths. Okay, well, what's the halfway point between 32 and 16? Well, one way to do that, right, is just say, okay, they're 16 apart, so I could either add 8 to this smaller one or subtract 8 from this one, I get 24. Or another way, some of you might have saw, was to get the mean of those. 32 plus 16 is 48, divided by two values. 48 divided by 2 is 24. So our halfway point would be 24. So x minus 24 in absolute values equals, how far away were they? Right? They were 8 away. And notice that if you solve these two equations, you would end up getting the two resultant linear equations, x minus 24 equals 8, x minus 24 equals negative 8, you would get 16 and 32. Okay, so those were situations where we had one absolute value, okay, on just one side. The other side was not. Now we're going to get into situations where we have solving equations with two absolute values. So both sides have absolute values, okay? Well, all you have to do for those is basically keep one side the same as what's in the absolute values and the other side the same, and then keep that left side the same and take the opposite of all of what's in the absolute value on the other sides, which is why we have the parentheses here for the negative, okay? And by the way, if you wanted to keep the cx plus d the same and take the opposite in one of them of the ax plus b, that would obviously work too. Now think about it. Why does this work? Like, I mean, I don't want you just to go, oh, well, Mr. Kalin said to do it this way, this is how we do it. Why? Think about it. Think about it. If ax plus b, if what was inside here is the same as what's inside of here, yeah, obviously then their absolute values would be equal, right? But what if ax plus b had a value that was the opposite of what cx plus d's value was? So let's say ax plus b equaled 20 or something, and cx plus d equaled negative 20. Well, when we take the absolute value of negative 20 and the absolute value of 20, don't they both equal 20? They're equal, right? So that's why this works. That's why, and hopefully that understanding helps you to be able to kind of do these. Okay, so here's an example. You can try this one on your own if you feel comfortable. Otherwise, watch, and then we'll practice it with another one. So I can set 3x minus 4 to be equal to x, or I want 3x minus 4 to be equal to negative x, the opposite of x. And then we just need to solve those, right? So we need to get our x's together. So I subtracted 3x from both sides, and then what would I do to get x by itself? Or get 1x, I would divide both sides by negative 2, and I would get 2. And on this one, I subtracted 3x, I would divide by negative 4, and I get 1. Go back to your original and check it. Let's plug 2 in first. 3 times 2 is 6. 6 minus 4 is 2. The absolute value of 2 is 2, so I get 2 on the left side. And when I plug in 2 over here, the absolute value of 2 is 2. 2 equals 2. So that one checks. Here, if I plug in 1, 3 times 1 is 3, minus 4 is negative 1. The absolute value of that is positive 1. And when I plug in 1 here, obviously, the absolute value of 1 is 1. 1 equals 1. So they both check. So check, check. Our solution is 1, 2. All right. Go ahead and try this one on your own. Key thing, remember, when you take the opposite of one of the sides, make sure you use parentheses so that it goes to the whole thing. Okay, so go ahead and give it a shot. All right, so I want 4x minus 10 to equal what's on the other side, or I want it to equal the opposite. So I put a negative sign in here of what's on the other side. Okay, and by the way, I could have kept this side the same, and instead, of having 4x minus 10, I could have had negative parentheses 4x minus 10. Wouldn't matter. You could do it either way and it would work out. Then it's a matter of just solving this, right? So simplify each side separately. So first we're going to distribute the 2 and get 6x and positive 2. Get your variable terms together. So I'm guessing I probably subtracted 4x from both sides. Let's see. Yeah, I did. And that would get me 2x. And then what else did I do? I subtracted 2 from both sides, got negative 12, and then divided by 2, so x equals negative 6. And on this side, similar pattern, right? We're going to distribute. This time we get negatives over there. And I guess I added 6x to both sides. Let's see, and probably added 10 to both sides. Let's see if that's what I did. Yeah. And then divide by 10, and we get 4/5. By the way, if you're on a quiz or test and you're running out of time, maybe you don't check both of these. Maybe you plug one in and hope that you probably got the other one right. Chances are if you got one, you probably got both. And then if you had time, go back at the end and check them both. Okay. Now, sometimes you got to be careful. Sometimes when you do these, you might get an extraneous solution. That's like an apparent solution which must be rejected because it does not satisfy the original equation. In other words, you might solve it, but when you plug it back in, it doesn't work. Okay? So let's look at this. Notice we don't have an absolute value on this side and we have a variable. And that's when we're going to see these possible extraneous solutions. And see if you can think of the reason why as we go through this. Okay, so again, we kind of set it up the same way. We want 2x plus 12 to equal 4x, or 2x plus to equal the opposite of 4x. Let's solve these. So I probably subtracted 2x from both sides. So I have 12 equals 2x. Divide by 2 and get x. Oops, what happened there? X equals 6. Okay. Then over here, we are probably going to subtract 2x from both sides, is my guess. And then divide by -6 and get -2. Okay, now let's plug these in and see if they both work. If I plug a 6 in, 2 times 6 is 12. 12 plus 12 is 24. What's the absolute value of 24? 24. 4 times 6 is 24. 24 equals 24. So this one checks. That one's good. What about this one? -2. 2 times -2 is -4. -4 plus 12 is 8. Absolute value of that is 8. And when I plug -2 in over here, 4 times -2 is, -8. So I get 8 equals -8. Yikes. That doesn't work, does it? So do both work? No. So what do? We basically get rid of this. You could almost think of it like you might even want to write extraneous, or you like just kind of cross it off, and then this would be our boxed answer. This is our only solution that works. Now, question for you. Why didn't this work? What do you think is interesting about the solution here? Yeah, it's the fact that if x can be a negative, that's going to make this side negative. And can an absolute value ever equal a negative? Absolutely not. So the moral of the story is be very careful with these. You always want to check your work. Okay. All right, so try these, or try this one, and then pause the video and then come back. Okay, so the way I did it was I said x plus 5 equal to x plus 11, and then x plus 5 equal to the opposite of all of x plus 11. And oh my goodness, watch that. What's going to happen here? Could this ever be true, this equation? X and x plus 5 and plus 11? No. Yeah, that's afraid not, right? And then over here, distribute. Add x to both sides. So I added an x to both sides, got 2x. Subtracted 5 from both sides. So I got my variable terms on the left, my constant terms on the right. So -11 and -5 is -16. Divide by 2, we get -8. Let's see if that one works. -8 plus 5 is -3. Absolute value of that is 3. -8 plus 11 is +3. Absolute value of that is 3. 3 equals 3. Check, check. Yes, it does. All right, and that does it for 1.4. Again, make sure you've got some good understanding on this. Come see me at contact time, or make an appointment for another time if you're busy at contact time. Happy to help you. Try other resources. Call a friend. Ask an older sibling. All kinds of ways that you can make sure you've got a good handle on this. And I look forward to helping you out with this in our next class. Bye.